Okay, Ken. So yeah, Marin Stella paper 2. Question 5, part 1. Calculate the coordinates of the points of intersection of the graph y equals to modulus 2x minus 5 minus 3. So that is this graph over here. I know I didn't go through absolute value function with you. It's because it's no longer in the AMAX syllabus for many years. I only go through one question with you. Let me just quickly run through how to do this question. Okay. So if I gave you y equals to 2x minus 5 minus 3, can you draw the graph?
Y equals to x minus 3.
Minus 5 minus 3 without modulus.
You just like make a no, then a something like if x is like
yes, you can just plot x and y, right? So then you just get a straight line. But then more importantly, minus 5 minus 3 here, what does it become? Minus 8, right? So 2x minus 8, which is mx plus c. Without plotting points, can you tell how the graph will look?
yeah, and y intercept. Yeah.
Draw a sketch for me. Is your iPad working?
Yeah. When x is 0, then y is minus 8. So maybe like here, and
Yes.
just like pass through here. Something like that.
Correct. Very good. Exactly. Okay. Now that is for the case where you have 2x minus 8. But when you now actually have a pair of modulus signs, so y equals to 2x minus 5 minus 3, but you put modulus sign around 2x minus 5. Can you still do the same thing?
No.
Actually, you can if x is positive. If x is very, very big. Imagine if x is very, very big, positive as in big as in positive, then it means that 2x minus 5 will be positive as well, right? Assuming that you can have x to be very big, which means that if you take the modulus of this very big number, it's as if the modulus is not there, right? Because it's already positive. Then it means that this would be, when x is very big, this will be exactly the same as 2x minus 5 minus 3. So maybe the graph will be exactly the same as whatever you've drawn just now, this guy, y equal to 2x minus 8. But that's only when x is very big, the right half. For the left half, we are not sure, right? We're not sure. So that's why we have to be a bit more creative when we are trying to draw the graph of this guy. So let me tell you what's the procedure. So what you do is you start off with whatever is in between the modular signs, 2x minus 5. You can draw the graph, right? Here I did it step by step. Y equal to x like this, 2x make it steeper, 2x minus 5 means you bring it down 5 units. Can you see? I brought this down by 5 units. Okay, 2x minus 5, clear. But what happens if you take the modulus of 2x minus 5? This guy. Modulus means what?
Modulus means must be positive.
Correct. When is the graph negative? Correct, exactly. Yes.
Actually, yeah.
Yeah, correct. You just have to draw this part, drop the left leg. The part of the graph that's negative, you drop it. So that's why you get this.
Positive 5, really? Or it will pass through.
Correct, exactly. It will be positive 5. It will reflect. You can try substitute x equal to 0, what do you get? Over here, if you sub x equal to 0, what do you get? Y equals to 2 times 0 minus 5, which is negative 5, but you take modulus of negative 5. Modulus makes negative numbers positive, so positive 5. Can? Or absolute value. That button is actually available on a scientific calculator. Do you know where it is? ABS.
ABS.
Yeah, ABS, the button.
Oh, apps. Oh, yeah.
The two vertical lines, right? Okay, so if you really don't know how to manually calculate, you can use a calculator. I usually don't use calculator for absolute. Just type. I use a calculator for the inside the inner part, then modulus just change the sign. 0 stays 0, positive stay positive, negative change back to positive. Okay, that is modulus 2x minus 5. We are not done yet because at this stage, you are able to find the x-intercept, right? Over here. Just sub in y equal to 0, then you can solve for x. You get 5 over 2. Is that okay? 5 over 2 comma 0. Good. So that is that is modulus 2x minus 5. We're not done yet because the actual graph has a actual function
minus 3.
Modulus 2x minus 5 with an additional minus 3. So what does it mean when you minus 3? You shift the graph down by 3 units. So if here is positive 5, you shift down by 3. Where does it go?
Positive 2.
Positive 2 or 5 minus 3. Then how about this point? 5 over 2 comma 0. You shift it
5
down.
over 2, comma
minus 3. Yes, the y coordinate will reduce by 3. Okay, but as a result, what do you notice about the graph? It will look something like this, right? And there are 2 more points here and here intersecting with the x-axis. Previously, the intersection with the x-axis only 5 over 2 comma 0. Now it becomes these 2 points. It's a 1 and a 4. How do you find out it's 1 and 4?
I know it's 1 and 4.
Yeah, how do you know it's 1 and 4? So, one way is to realize that they are the average of these 2 numbers will give you 5 over 2. And it's symmetrical. Another way that's less geometry involved, doesn't involve so much geometry, is to sub y equal to 0. Yes. Then you need to remember how to solve modulus equations. So here's how you do it. You take this guy equal to 0 because you replace y with 0. Sub y equal to 0 here. I just put 0 on the left side, but then I swap left and right. Then you bring the minus 3 over, become positive 3. At this stage, you must memorize this. Modulus of a positive number, that makes sense, right? Modulus of a positive number. If you get modulus x equals to negative 2, does this make sense?
No.
Doesn't make sense, right? Because modulus will make things positive or 0. Yes, undefined. Okay, so this is nonsense. You won't see this. Positive, it makes sense. Let's carry on. Once you have something that makes sense, you can split up. The 2x minus 5 equals positive 3, or the 2x minus 5 equals negative 3. Okay, then from there, you have 2 equations. You can solve for x. Okay, that's it. Why? Maybe you're thinking, how come modulus need a plus and minus? Why?
How come? Oh, because it can be negative or positive. Like as in the wait. Yeah, as in like this one can be negative or positive or something.
Yes, correct. That's the correct reason. Yeah. Another way to interpret is to look at a graph. Let me zoom out. I hope you can still see. 2x minus 5 equal to 3 is the same as y1 on the left and y2 on the right. So when you solve y1 equal to y2, what you're doing is you're drawing the graph of y1, graph of y2, find point of intersection. So this is 2x minus 5, which is your y1, right? This guy. Then y2, you just draw in y equal to 3 over here, right? Y equal to 3. Then there are 2 points, right? It must be plus or minus. It has to be plus or minus. The reason is that, okay, maybe a clearer picture will be like this. This is y equal modulus 2x minus 5. Then positive 3 and negative 3 looks like this. This is y equals to, this is y equals to 3. This is y equals to negative 3. This modulus 2x minus 5, you split it up into these 2, right? Which is 2x minus 5 equal to positive 3, 2x minus 5 equal negative 3. So it means that we drop the modulus and we focus only on 2x minus 5. How does that graph look? Just 2x minus 5. It looks like this. Can you see? Like the bottom half went up, but before that, it was the original 2x minus 5. Then the intersections, where are they? It's over here and here. Can you see? But when we find the point of intersection, that's okay. That's maybe interesting on its own, but more importantly, we're trying to solve for x. So we are looking at the corresponding x coordinate, which means you focus on the x coordinate of those 2 points. you realize that, hey, this particular x coordinate is very interesting. It's the same as the intersection, the x coordinate of the point of intersection directly above this point at the top, right? So that means that this x value and this x value, these two x values are the same. Let me label it. Same x coordinate. So that's why you can just take 2x minus 5, y equal to 3, y equal to -3. Then you find a point of intersection. I mean, solve for the x coordinate of the point of intersection. You'll get the answer. Another way is you start with modulus 2x minus 5 equals to 3. You can split it up as positive 2x minus 5, positive 2x minus 5 equals to 3, or negative 2x minus 5 equals to 3. Okay, negative with bracket. Of course, this plus with bracket, you don't need to write it up. So I'll just get rid of it. I just wrote it so it looks symmetrical. 1 plus 1 minus. This will also work. Can you see why?
Yeah.
Because okay, I'll just quickly explain. 2x minus 5 is this blue one. Negative of 2x minus 5 is actually this guy.
Yeah.
One I'm highlighting. Can see how. Then the intersection with x equal to 3 is really just saying this guy, and this guy. You find a point of intersection here and there. A bit messy, yeah. But do you get what I'm saying?
I think so.
Yeah. Okay, maybe I draw a quick graph. This idea means you got 2x minus 5, y equals 2x minus 5, which is this graph. Then negative bracket 2x minus 5. You can go and check it on your own. You go and plot a few points. It will be this guy, y equals to negative bracket 2x minus 5. They will have the same, what is it, 5 over 2. Or is it 2 over 5? Let me double check. 5 over 2. X coord as the x-intercept. Then y equal to 3. Y equal to 3 is this guy here. Y equal to 3. Let me just label a few more points. Here is positive 5, there is negative 5. And this point here is positive 3. So the point of intersection over here and there, this is what we are solving in this second equation. Or rather, the x coordinate of these 2 points of intersections. And they are the same as taking which two? These two. Right. Okay, maybe I don't draw this point here. I'll just label these 2 points to represent this method of solution, and these 2 points to represent this method of solution. Is that clear? I draw a line to separate. Yeah. Okay. This is linked to this, and that is linked to that. Maybe I use a different color. I use pink. These two are linked. These two are linked. Okay, very messy. I hope you understand. Okay, you can go and solve this on your own. Solve these two. Solve, and you will end up with x equal to 4, x equal to 1. Okay? Can?
Okay.
Okay, good. That is the part 1. Let me just see the question paper. Part 2 is hence sketch the graph of this guy. Yeah, we already did part 1 and part 2 at the same time. Okay, clear? Question 5? Modulus graph. Can move on. Which is the next question. Most of them are correct. Something wrong with question 8 part 1. Let's take a look. The equation of the curve is y equals to, let me write it down, y equals to kx squared plus 4x plus 3 plus k. This is the quadratic part, quad. This is the linear part. And the last portion here is the constant, 3 plus k. Part 1, find the range of values of k for which the curve lies completely above the x-axis. Completely above. Can you have a graph that looks like this? A set face and completely above the x?
Because you will extend.
Yes, you will extend and you hit the graph. Very good. You didn't fall for the trick. So that cannot be set face, then must be a
happy face.
Happy face. Okay, so it must look like this. Okay, and extend upwards so it won't ever cut the x-axis. Okay, so what is so special about this graph? B squared minus 4ac less than 0. Exactly what you did here. Very, very good. Blah, 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 blah. Finally, you get these two parts. Then you rejected -4. Why? Because if you...
-4 would be like that one, no?
-1.
Mm.
Correct. Yes, if it's less than -4, then it means that your graph will go below the x-axis. Okay, actually, let me just double check first. More than 0. Correct. Yes. You cannot have -4 because the moment you're less than -4, you can just quickly check if you sub in x equal to 0. Like let's say it's -5, then -5x squared plus 4x plus 3 minus 5, which is -2. If x is equal to 0, y will be equals to 0 plus 0 minus 2, which is -2. Then that means that you have a graph that cuts through 0, -2. Sorry, somewhere more like here. It doesn't have to be the turning point. Could be something like this. Which means that there will be a part of the graph that's not entirely above. So you have to reject. Okay, good. But then I have to say one more thing. Since this A is more than 0, you mentioned, right? This A actually represents what thing?
The A like ax squared plus bx plus c. Like the
but
A.
this question got A, man?
No. It's
what is it?
K.
It's
Wait,
K.
it's...
So you need to contextualize. Instead of saying A more than 0, it's K more than 0. Okay? Makes sense, huh? Positive coefficient x squared, happy face, right? Yes, you got the right concept, but don't just use the letter A, contextualize. In this case, it's not A, it's a K. So K more than 0. But then you got K more than 1, right? So how? Oh, wait a minute. K more than 0 and K more than 1. Did I read it wrongly? Let me double check first. Oh, this is K more than 1. Sorry. Okay, please ignore my answer over here. I made a mistake. Wrong. K more than 1 and K more than 0. There are two conditions you need to satisfy at the same time, which implies that you must satisfy which one? You draw a number line. Here is 0, here is 1. You want K to be more than 0, K to be more than 1. Then you find the overlap, which is really just K more than 1. That's your final answer. You cannot have K more than 0. You put down a therefore and then K more than 0, then that's wrong. Should be K more than 1. The stricter condition. This should be the final answer. Is it clear? You need to satisfy both conditions. For you to be happy face, coefficient x squared more than 0, so K more than 0. To have discriminant less than 0, you get K more than 1. This is clearly rejected already. So you have these two conditions. Which one is stricter? This is stricter. You accept the stricter condition, K more than 1. Or actually, more technically, should be the overlap of the regions you want to accept. Okay? Can Okay, next. Can't remember. It's been a while. Question 10, part 2. What's that? The function f is defined by f of x. Question 10. By f of x equals to 2 cosine square x minus 6 sine square x. Wow, square of cosine square of sine, I don't know how to graph. So I have to make use of the part 1, part 2 to help me. Part 1, show that fx can be expressed as 4 cosine 2x minus 2. Blah, 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 you managed to show it. Very good. Now no more square. I know how to draw this graph. Right? Yes. I gave the final answer already, I think. Oh, no. Part 2 is state the minimum value first. I give you some hints here. You want to read?
For sine or cosine inverse, usually always in between -1, +1. So -1 less than, so 4 times -4. So just -4 minus -6.
Very good, -6. Yep. You times 4. Okay, I just show you the working. 4 times cosine 2x, so it's bounded between -4, +4. Then how do you go from 4 cosine x to 4 cosine 2x to 4 cosine 2x minus 2? Both sides need to minus 2. Minus 2, minus 2, which is -6 and +2. So this one free gift. Free gift. You found the, what do you call this? Instead of minimum, it's the
Maximum.
maximum. Very good. Okay, so you answer the extra question. So now that you know minimum and maximum, you can draw the graph already, right? Oh, sorry, part 4 is a bit different. Oh, this one definitely you never see before. Sorry, I didn't go through with you. Oh, it's the whole syllabus. This is modulus of trigo graph. Too difficult, remove from syllabus, but I'll just explain it. So part 3, you know the period. Yes, just have to look at the 2x, then the standard 360 degrees or 2 pi radians divided by 2. Okay, then let me teach you how to draw this graph. Okay, so I'll just show you what's going on first. So first you must realize, because there is a what's a graph? 4 times cosine 2x, right? We focus on this first. We ignore -2 for now. For cosine 2x, it's just down, down, up, up, right? Cosine 2x. Don't care about the 2 lah, right? 2 is just telling you that within 0 to 360, it will appear 2 times.
Yeah.
Okay, 0 to 360 or 2 pi. It will appear 2 times. Down, down, up, up. First time, down, down, up, up. Second time. Halfway in the middle is pi. But read the question carefully. Sketch the graph of y equals to modulus fx for 0 less than equal x less than equal to pi, not 2 pi. So that just means we only need one piece of the puzzle. I mean, 1/2 of the graph. We only need the one that I circled in blue. Understand? Before you take modulus. Is it clear?
Yeah.
Okay, so this is y equals cosine 2x, +1, -1, standard. But now if I multiply it by 4, what happens? Very simple. 1 -1 becomes 4 -4. Okay? Over here is pi. Sorry, messy graph. Understand this part? This is y equals to 4 cos 2x. Very good. Now, we are not done. We have a -2. So what do? Shift the graph down by 2 units, which is what I have over here. The middle line, right? You know how the graph, you go down, down, up, up. It's symmetrical about the x-axis, right? Then this is like the middle line, y equals 0. So if you -2 now, this -2, what you do is you take the middle line, you shift it down by 2 units as well. So y equals 0 becomes y equals -2. Is that okay?
Yeah.
Very good. So with the middle line, then you're able to draw down, down, up, up with reference to the middle line. Okay, cosine graph is down, down, up, up. And the maximum and minimum 2, -6. We already figured that out from part 2. Remember? Here?
Yeah.
That's why you got 2, -6. Just -2, -2. So that's the normal graph, y equal fx. But now you need modulus of that. What do? Modulus.
Negative to positive.
So the bottom part, you see, look carefully. This one is down, curved this way. So I make it more dramatic, curved this way. Can you see it's like a circle? It's the top right corner of a circle. But a bit sharper, It's not exactly a circle. Circle looks like this. Cosine graph is a bit more, sorry, what do you call this? Steeper? Yeah, steeper. Or is it gentler? I can't tell. Yeah, it's like this, don't stretch out so far. This part is a bit more sharp. Then after that, it's curved this way. Can you see that it's, I make it more dramatic, like this. It's like the bottom left of a circle. Can you see? Right, let me get rid of this. This piece here is like the bottom left of a circle. Can you see that?
Yeah.
And then after that is the bottom right, and this part is the top left. Clear? About the curvature, like this, like this, like this, then like this.
Yeah.
But it's just that this part is a bit longer. These two parts are a bit shorter. Then how do you flip it up? So let me show you my art skills. Oh, this one, I spent some time trying to draw this. If you curve downwards this way, right, can you see? Sorry, I work with the original graph. If you curve downwards this way, we reflect it up, it will curve the other direction this way. I'll use pink color, I guess. Orange. Can you see the symmetry? Then after that, this piece here at the bottom, you curve this way, you reflect, it will curve. You want to try drawing?
Try drawing.
Yes. This piece.
It will be. Why is it not? Okay, it's not working.
Okay. So
I promise I promise I know what it looks like though.
Okay. Basically, if you have this part is a bottom left corner of a circle, you reflect, it will become it's working. Very good, exactly. It become the top left corner. Oh, like you just draw a circle, I think you can see already. Bottom left, reflect, become top left. Okay, how about this part? Okay, wait, I draw first. Like this, roughly, Okay, then how about this part? Just go down, I'm sure you know this.
Yeah.
But you must stop here, and then must be careful. This part becomes that part.
Yeah.
Okay, clear?
Okay.
Then finally we get this weird looking graph. All right. Can now take note that because this left half, so this short piece that got reflected, right? It only drops until the middle line, which is until -2. So what's the vertical distance over here? The vertical distance over here, this part. From 0 to -2, what's the length of this blue color arrow? Line segment. How many units? 20 units? 6 units? No, 2 units only, right? So that means equivalently over here, it will also be 2 units because you reflect upwards. Yes? Clear?
Yeah.
Clear or not clear? Yes. Okay, very good. So that means over here, it will be the same height, +2. That's why I have to very precisely draw my graph like this. It's the same height. Okay? This curve and this curve must stop here. Exactly same height as this +2. Are we clear? Yes?
Yeah.
Okay. How come got another piece? Oh, right. This piece that was originally already positive. You take the modulus, it's still positive. And finally, we have our modulus graph like this. Okay, very good. Now read the question. Can you read for me? Part 4. I drink some water. Question 10, part 4, Marie Stella, SA2.
Read out
now.
Okay. Wait, read out.
Okay, don't you read out loud, but okay, have you finished reading it? Let me know when you're done reading. Telegram can search Maris Stella.
Oh yeah, sketch the graph. Sketch the graph. Yeah, okay, I know what it means.
Okay, can
Yeah.
Done. Okay, good. So this is the graph of y equals modulus fx, right?
Okay.
They're asking you for number of solutions of modulus fx equals c. What does that mean? Means the left side is your y1, right side is your y2. I already draw my y1. Maybe I'll use red color to color code. This is y1. Then y2 is equal to c. How does the graph of y2 equal to c look like? C being a constant, right?
Yeah.
So y2 equals to a constant c, horizontal line, right? Okay, this one Sec 3 E Math. Sometimes Sec 2 students also learn this. Constant, then it's a horizontal line. But you need, read the question, given that number of solutions is equal to 4, right? Which means that you have how many point of intersections between y equal to c, the y2 equal to c, and the y1 equal modulus fx. Number of solutions is
4.
So how many point of intersection?
4.
Also 4. Exactly. Same number of solution is the same as number of point of intersection between y1 and y2. You got y1, now you have to draw y2. I already draw for you y equal to c. I just didn't put the label subscript 2. So if you draw here, can we have that 4 point of intersection? Okay, I move my graph around. I move to the top here. Is that correct? 4 point of intersection. Maybe I change to blue. Keep to the same color. Oops, wrong. This one. Yeah. Yes or no? Cut here and here. Is it 4?
No.
Clearly not. If you move all the way on top like this, tangent, 1 point only. Correct or wrong? Wrong. So you have to keep on shifting it down, 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 down. This one 1 only wrong. This one 2 wrong, 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 until you reach here. It's still 2. Cannot continue going down, 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 down. You hit here. How many points of intersection?
4.
4. Very good. So this is acceptable. This is an acceptable value of c, which is y equals to
Y equals to 4.
no. Oh,
y equals to 2.
Y equal to 2, yes. But then if you have 1.5, is that 4 point of intersection? You see, I just shifted it downwards a bit.
Yeah, it's still 4 point of intersection.
Still 4, huh?
So it's
how about
range.
this one? 0.5? Correct, it's a range.
Oh,
0.5 can?
Y more than 0? Wait, no.
Exactly equal to 0 count.
0 less than 2.
Okay.
Less than or equal to 2.
C
because 0 it
sandwich in between.
If it's 0, then it's only 2 solutions.
Okay, so this one, no equal. Because if exactly what you said, there will only be 2 points of intersection. But how about this part? Can C be equal to 2? Ding, ding,
Can.
ding, ding. Can. So you have to put an equal sign. Have to put an equal sign. And yes, equal. If you can understand this, you're ready for H2 math. If you can understand this, you are ready for H2 math. This is the most difficult question in a topic known as graphical transformations. So yeah, ignore the 0, accept the 2. Clear? Oh, this question is very difficult. Why? Because you need to know a lot of different concepts. You need to know trigo identity. You need to know how to do trigo graph drawing. Then you need to know modulus. And you need to understand the concept of number of point of intersection is the same as number of solutions. Then you need to know what's y equal to c. Some students, when they see letters, they get confused. Y equal to c. What's c? It's not a number. I tell them y equals to 6, they can draw. Y equals to 5, they can draw. Y equal to c, they are confused. Because it's a letter. It's a range of values. C can be any value in a certain range. Okay, but yeah, that's enough nonsense. But do you get what's going on here?
Yeah.
Can Okay, very good. Let's move on. Okay, good. Draw the circle C2. Yeah. This one must draw the circle, then you understand. Okay, let's take a look at question 12b. So for question 12b, okay, help me to clear that drawing. Yeah. Okay, so you got the circle, center 3, -4, radius 7 units. Very good. So what is that circle? That's circle C1. Totally irrelevant to part 2, part 3.
Yeah.
Okay, so we can ignore it. Yeah, so second circle C2 has a diameter SR. The point R has coordinates 2, -2. Equation of tangent to C2 at S is 4y minus 3x equals 6. Part 2, find the equation of SR and hence show that the coordinates of S is -4, 6. Okay, can understand the picture I just draw?
But how do you know?
It will look like this, right? I explained below. Okay, where can S be? That should be your first question.
Yeah.
In order to know that, you must understand that there is a very important information related to S. The tangent line to the circle C2 is at point S. And it follows the equation L, I label as capital L, 4y minus 3x equal 36. Okay, let's start with this. Start with the tangent. If you make y the subject, what do you get? You end up with 3x over 4 plus 36 over 4.
Oh, so you know it's like, you know it's like this.
Positive slope.
The gradient is not like this, not like this, not like this, not like this.
Very good. Yes.
Oh,
so
okay.
that's why you look at
like this or like this.
Correct. It's either like this or like this, tangent to a circle. Understand now? So there's only two possibilities.
Now, how do you know which one it is?
Guess and check. Guess and check. Okay. So, oh, sorry, not guess and check. Both cases will work. What was the reason? Let me think again. I forgot. Wait a minute. That could be two circles. Oh yeah. Sorry, I just saw it. These are two possible circles, right? Look, if your tangent at S here, your point R is 2, -2. It could be here, it could be there. Which one is which? Never mind. At this stage, you're not sure, right? Just consider both cases. Just consider both cases. Then you try and check one by one and see which one works, which one doesn't. Let's start with the first case. The tangent is at the bottom right. Okay? And the point S is at the bottom right of the circle. Then assume that because it's a diameter SR, it must be directly across. Did you catch that? The point R must be directly across. Okay, good. And if it's a diameter, it's really just two radiuses. If you focus on this radius and you focus on a tangent, what angle do you get over here? Sec 3 proofs in plane geometry.
Yeah, 90.
90 degrees, very good. How come no 0 here? Sorry. Yeah, 90 degrees, okay? So that means that you have perpendicular lines, right? If you have perpendicular line, can you find the gradient of this SR? The tangent line equation.
It's just
the gradient is 3 over 4.
Minus 1 divided by 3. Oh, so -4 over 3.
So MSR equals to -1 over 3 over 4, which is
then you have point R. So then you can just do point slope.
Yes, exactly. Clever question, right? You have to draw the picture, then you understand. Draw. Must draw. Hey, once you draw it, it's very clear. Okay, so point slope formula, how do you do it? Tell me. Oh, you're writing? Oh, okay. Carry on. Point slope. Okay, can. Yes. The way I taught you.
Wait, remove the subscript.
Yeah, don't need subscript. Just sub in one of the y and x. Perfect. That's it. What's M? You already know what's the gradient of SR?
Wait, sorry.
M is what? M is the gradient of the perpendicular line. -4 over 3. Okay, that's it. That's a formula. That's the equation. Okay, let's simplify it. I'll copy down what you wrote.
-2 times
y plus
3 and -4.
Oh. Let's see. Yeah, correct. Yes. Good. Okay, let's just simplify this. -4 over 3x. Positive 2 times what? 8 over 3. Don't forget to -2. Well, how come yours is -4? Let me just check again. How come got 4?
I mean -2.
-2, yes. Correct, that makes more sense. Okay, let's simplify this a bit. -4 thirds x, 8/3 minus 2. Use a calculator and I get positive 2/3. So now let's double check with the equation. Does this make sense? Does this look like a -4/3x plus 2/3? Yes, yes.
Like, yeah.
Looks like it. Negative gradient, positive y-intercept, not sure where it is. What was the actual question asking? Part 2, find the equation of SR. Okay, so now that we got the equation SR, this is for the first case, right? When you remember there's 2 cases, here and here. Tangent bottom right or top left. So now let's consider, would this still make sense if we instead had the other case? I'll just draw a quick sketch. Circle, tangent, SR. Then this would be this would be point S, there would be point R. Does it make sense? Let's write down the, let me see, was the coordinates of S given? Oh, it wasn't given. Oh, that's the next part. Show that the coordinates of S is -4, 6. Okay. Which is the correct one? There's only one correct answer, sorry, because you need to find the coordinates of S. Let's think about it. The tangent line here is L, which is 4y minus 3x equals 36. Which one looks more correct? Not sure, huh? But let's label whatever we know first. We know the equation of SR, right?
Yeah.
This guy?
Yeah.
Okay, label. Okay, let's say L2. This one L1. L2 is negative y equals -4 x. You just write it nicely. Plus 2/3. Okay. Then how? What is the question asking? Find the coordinates of S.
Yeah.
L2, L1. Equation.
L2, L1. Sub in. Oh, okay. Okay. Oh, okay. What? Okay. Sub 2 into 1.
Yes, y equal. Equate them together. Solve for x.
Okay, yeah.
Can I just use
Then
software to solve this?
Equal -4. Sub -4 into here. And then I think you get y equals
L1. Exactly, you will. Correct. Let me just use software to solve this. I'm sure you know how to solve simultaneous equations. I'm not gonna bore you. Okay, I need to share screen. How do I share screen? Let me see. Share. Let me share the correct screen. Give me a second. This guy? No, wrong. Correct screen is this guy. Okay, so the first equation is y equals to -4 x plus 2/3. The next one is y equals to 3/4 x plus 36/4. Okay, can see the red and blue line, right? Those are the 2 lines. Then here's the point of intersection, -4, 6. Done. Okay. Can okay, then that's the point S. So now that you know it's -4, 6, let's go back to the iPad screen. Okay. Wait a second. Hold on. And we're back. Okay, what was the coordinates again? -4, 6. So which one makes more sense? -4, 6. This one or here as negative 4, 6. Which one makes more sense?
Which one makes more sense?
Let's focus on the
The-
x coordinates.
The
2, negative 4. Negative 4, 2.
yeah, okay. I mean, S makes the left one makes more sense. Cause
The black and blue one makes more sense, right? Negative 4 should be on the left, 2 should be on the right. Okay, so even though we started with a wrong diagram, because we are following the procedure simultaneous equations, we never make too many assumptions. Like the x coordinate is of r is smaller than s, which is clearly wrong. 2 is not smaller than negative 4. So we are able to still get the right answer. Okay, that's the power of coordinate geometry. Okay, Ken, that's it. That's all I want to say for this question. Can I move on? Okay. Sorry, one more part 3. Sorry, I forgot. Find the radius and the coordinates of the center of C2. You got a point S, you got a point R. SR is a diameter. How do you, can you find the length of the diameter? Do you remember the formula?
Diameter.
I mean, don't care that it's diameter. You have a point, Can you find the length?
Distance.
Distance formula. Is it clear to you?
Yes.
Yes, then diameter, this is really a diameter that's given by the question. Okay, circle C2 has a diameter SR. So how do you find the radius?
Divide by 2.
Divide by 2, exactly. I'll leave that as a homework to you, or you can read the solution. Then how about the coordinates of the center?
Midpoint.
Very good, it's the midpoint. So negative 4 plus 2 divided by 2. 6 plus negative 2 divided by 2. Then you get the x.
2. Negative 1, 2.
Yeah. Yes. Okay, Ken. That's it. Let us move on. I think you get it. This one, just add one more comment. Just use coordinate geometry. Maybe I should clarify. I'll use a different color. This is thumbs up, correct? This. No. Bad. How do I? This one is correct. This one is wrong. Okay. Good. This one is bad, but still okay, because we can use coordinate geometry. Oh, we reached the end. Okay, very nice. Okay, I think I spent a bit too much time on this already. Let's move on. Okay, I need to go through your paper. Let me just take a look at your solution. Which are the ones you did wrongly? Or not do wrongly, more like can do a bit more efficiently. Question 16. Okay, let me take a look at your question 16. Okay, I am going to annotate on my own paper. Is that okay? Like I don't open your file, I'm just gonna start writing. Yeah. Okay, let's start. So today is 230113. Brandon, let me just write down your name. So we want to go through Xingli rate of change, connected rate of change. What's the topic? It's what's the question? Question 16. Okay, so in your answer, what you did was, okay, you got the file open? Xingli? Can okay, I'll just copy down some of the key information. X squared y equal to 24 ... You end up with dy by dt sub in x equal to 2 equals to -3/10. Okay, in between that, you already found the expression for dy by dt, but you immediately sub in x equal to 2 to save time, like this. -3, sorry. Right?
Yeah.
Now, this is a bad practice. I strongly recommend you to find dy by dt first without substituting the x. Okay? So what I mean is, add in one more extra line like this, just the exact same thing, okay, with x instead. And then at the side, you write down vertical line x equals to 2. Reason being, you can read. Okay, am I not sharing the screen? Oh my goodness. Sorry. Oh, yeah. Sorry. Oh, I thought you could see my screen. Sorry. 230113, Brendan, Xingli rate of change, x squared y equal to 24. Skip information. You found dy by dt given x equal to 2. You wrote this. You sub in x equal to 2 directly. But I'm recommending to you, write this instead. Write the expression with x,
Yeah.
then
And
vertical
then
x equal.
okay.
Reason, this
Yeah,
can be recycled. Okay, this is part 1. Part 2, part 2. Let's take a look at part 2. What did they ask? Wait a minute. Oh no, where did you go? Yeah, so for part 2, they're asking find the rate of change of y when y equals to 12. Okay, so basically they are still asking for dy by dt. Want to find dy by dt given that y equals to 12. Actually, there's a very, very simple way to do this. Okay, y equal to 12 is a problem here because the formula here you found involves what letter? Is it y? No,
X.
it's a letter x,
X.
a variable x. So, but we got y equal to 12. How do you link from y to x? I wonder if there's a formula that links me from y to x. Oh, if you look heavily at your working, you wrote down y equals 24 over x squared. Which means that you can make x the subject, right? Okay, maybe it's better if I didn't bring the x squared over. Keep the x squared on one side, you get 24 over y. And x equals to plus minus the square root of 24 over y. But they told you x is more than 0. But x is more than 0. Given x more than 0. And a bunch of other things. So that means which one can you reject? Or which one do you keep? When you take square root, you need plus minus, right? So
Yeah.
you have x more than 0. Which one do you keep?
You keep the positive one. Get rid of
Exactly. The other guy you reject. So this is the only answer. That means if you got a formula for x, you can just sub in y equal to 12. You have y equal to 12, sub in, and you get x. Once you get the x, you sub in. Don't need to redo the entire chain rule again. Let's check if the answer is the same. So if you get what I'm saying, right? I'll call this 1 into 1. This will give me x equals square root 24 over 12, which is square root 2. Okay, so that means that dy by dt sub in y equals to 12 is exactly equal to dy by dt sub in. This time, instead of y equal to 12, we have x equals square root 2, which is equal to the formula we found before. You see, I copy, I paste. You see what I just did? Copy and paste. But you just have to replace the x with square root 2. Can you see? Just one line only. You're just recycling part 1's information. This is a concept that's known in programming as memoization. Memo as in memo pad. Memory pad. If you write down your previously computed information neatly, you can recycle the information. So you don't need to waste time recalculating the same thing. You understand the idea? Use part 1's answer to help you answer part 2, part A to answer part B. You recycle the information, don't need to redo the same thing. This is called memoization. You memorize whatever you computed previously and you record it down nicely in your memory so that later you can just recall from your memory. Don't need to calculate again, waste time. Save this will help to save a lot of time and memory space. Yeah, anyways, you sub in x equals square root 2. Let's just do that. Use a calculator now. 48. I don't need exact answer. Square root 2 power negative 3 times 0.05. I got negative 0.848528. Is it the same as your answer? Let's see. Let's see, what was your answer? Yeah, it's the same. It's the same. Yes? Convinced?
Yeah.
Okay. Very good. So just remember to use your previous answers. Okay. But your method is fine. Your answer is correct for question 16. That's a bit long-winded. Next, question 17. Very good. Here's an alternative step. You can use long division before you do quotient rule. Okay, moving on. Please stop me if you need to. If not, I just keep on moving already. You had y equals to eventually, after you make y a subject, good. Y equals 10x over x minus 10. You could have done long division. Right, this is 1x, this is 10x. 10 divided by 1, you get 10 as a constant. 10, and you multiply into x, multiply into negative 10. You end up with 10x minus 100. Minus, bracket, bracket, draw a line. 10x minus 10x, 0. Or if you're lazy, you don't even need to write the 0. Then minus negative 10, because of the bracket, it becomes positive 100. 100 is like 100 times x power 0. Degree is 0. Here is power 1, so degree is 1. When your degree here is smaller, what do you do?
You remainder.
Very good. You stop. This is remainder equals r. This is the quotient, the answer. So the final answer, you can present it as quotient plus the remainder 100 over the divisor x minus 10. Then how to find dy by dx now? Differentiate term by term. This guy is?
Term by term.
Differentiate 10 and you get what?
0.
0. So easy. But you need to know how to do long division. Plus this one. Need to use quotient rule. You see fraction use quotient rule, right? Is there a smarter way?
See a quotient rule do fraction.
Wait. See a fraction, aka quotient. You use quotient rule.
Is there a faster way?
Is there a faster way?
I know there is, but I actually don't know what's the faster way.
Okay, I show you.
Bring up the
you.
x minus 10. What you mean?
Yes, exactly. Bring up the x minus 10.
The power minus 1.
There's an invisible power positive 1. Bring up, it becomes 100 multiplied by x minus 10 to the power of negative 1. 100 is just a coefficient. 100 is just a coefficient. Then, sorry. I should not be writing this down. If you want to bring it up, right, you have to copy down whatever was previously already written, put another equal sign, then you substitute this with this. Okay, before you do the differentiation. Differentiation must be done in one step. You don't go and write down 100 bracket x minus 10 power negative 1 in the dy by dx line. This is wrong. Are you clear? The bring up step is just algebra. You have not done differentiation here, which is wrong. Don't put it on the same line. Are we clear on this? Okay, so anyways, if you're clear on this, you will get this simpler expression to differentiate. Simpler in the sense that it is simpler to differentiate. Now you apply the differentiation rules. 100 is just coefficient, factor out. So leave it alone, then d by dx of x minus 10 power negative 1. But of course, if you're faster, you can just differentiate it in your head and then write down the answer. Just know that there's an invisible multiplication sign over here. So this will simply become, bring down the O power minus 1 to get the negative 1, bring down x minus 10 remains, the power bring down by 1, minus 1. Bring down the O power minus 1 to get the new power. Bring down the O power minus 1 to get the new. Base remains the same. Okay? Inside the bracket, it looks a bit funny, more complicated. What do you have to use?
Chain rule.
Chain rule. But then coincidentally, when you differentiate x minus 10, what do you get? Term by term, what do you get? 1 and a
1.
minus 0.
Yeah.
Right? Can which is just 1. So you times 1. Times 1, might as well not write it. Okay? But remember, there's a chain rule. Sometimes the question will trick you and give you 10 minus x. 10 minus x, haha. What's the derivative of 10 minus x?
Then derivative 10 minus x is -1.
-1. Very good. You finally understand. There's a negative sign, we better have a -1. Okay? You always give me a wrong answer when you see a negative coefficient. Please don't be tricked. Okay. Hey, I write it nicely. It's more like d by dx of 10 minus x equals -1. Box it up. Very good. That is the answer. We can make it look nicer by putting -100 on top, x minus 10 power 2 at the bottom. Do you realize that this is a lot shorter than quotient rule? Once you can do long division quickly, this to this, you can do in a few seconds.
Yeah.
Okay, very good. Let's move on. So that's all I wanted to talk about. You got the right answer anyways. 18 is good. Nothing to say. 15 and 19 is missing. Okay, let's try question 15 now. Question 15. Yeah, where is question 15? I need to get the question. Okay, question 15 is a trough. Okay, I'll just draw a quick sketch of the trough. Trough is just a container for, I think, cattle or cow or whatever kind of animals in a farm that to eat their food from, in case you didn't know.
Yeah, I didn't know that. I was like, what?
Yeah. Last time in kampong times, my parents' time, their leftover food will be placed inside here and the pigs will come and eat. Okay, it's the trough. Anyways, so this is what shape?
It's a prism.
Prism. What kind of base?
What kind of base? Triangle
read the
base.
question.
How you mean?
What kind of triangle?
Equilateral.
Equilateral.
X.
Read
All
the
the sides
question,
is X. Then the height
Very
is.
good.
Then the thing is 12.
Sorry, my diagram not very accurate. It looks more like isosceles. So let me just label them XXX and height H. So of course it's the same bottom for the front triangle and the back triangle. Height of the trough is 1.8. Its depth will decrease at a rate of 0.2. So this is a rate of change question. So we should always start off with WTF and given. So what do we want to find? What do we want to find?
What do we want to find?
Yeah, actually, sorry. I realized this question got two parts. First part, express V, volume of water that a trough can hold in terms of H first. Okay, this one is later. Sorry. This is part 2. Part 1 is the first step. V for volume of water. Volume of water that the trough can hold.
In terms of H.
Yeah, just pretend H is like a 9 or something. Just treat it like a number.
But then got the X. Then how do you
find the volume of a prism?
I thought it's just like it would be like 12 times height, half times height times base. So half times, so H over 2 HX over 2 then times 12. But then it says
yes, that's it.
But it says in terms of H, then I can have the X there.
Yes. Okay, okay, you got it already. Sorry, I just need to make one clarification. Units is in meters. I didn't read the question, sorry. So I should change meter cube. Let V meter cube be the volume of water which the trough can contain or hold in meters cube. Okay, so anyways, V is equals to the base area, which is half times base times height. Then you multiply by the length, 12 meters. So 12 over 2 is 6. Did I calculate wrongly? I don't think so. So it becomes 6xh. Is that correct?
Yeah.
Yes, right. So over here you're wondering, how come got a H and an X, 2 letters? Is that allowed? Here they are telling you that, oh wait, actually, yeah, you're right. It might not be allowed. Let me read the question again. Yes, you're right. It's not allowed. It's not allowed. Oh, that's why they say equilateral triangle. You need to start using some right-angled triangles. Search. Square root 3, square root 2. Okay, let's draw a cross section of the equilateral triangle. Square root 3, square root 2, nothing ringing inside your head.
Nothing. What?
Equilateral triangle, what's the angle here?
60. Oh, 60. Oh, wait.
I want to draw. Okay, go.
Okay, I'm thinking. Okay. Wait, but so you find. Wait. Is it you want to find this?
No, you're annoyed with the H, right?
Yeah.
So you don't want the H. But
Wait,
you're
but
okay with X.
So I thought it said show in terms of.
Sorry. Let me read the question. Or maybe I read wrongly. When the height of water in the trough is 1.8 later, and you're asking for in terms of H. Oh, sorry. Yeah, you're correct. Sorry. You love H. You hate X. Get rid of X. So your formula that involves X, let me write down the formula on the same page. You want to get rid, or in other words, you want to replace it with an expression in terms of H. Okay. How? Express X in terms of H. Mic test, I cannot hear you. Can you hear me?
Yes.
Okay. Think about it.
Okay.
It will cut half. So what's the length here? This perpendicular dotted line cuts the base X in half.
I mean,
so
this is like X over 2.
Okay.
Good. But, okay. Wait. What if sine 60 is...
So,
okay, this is X. X equals to H over sine 60. Does
wrong.
it?
Wrong.
No? Okay.
Look
Wait.
carefully. H over what? H over?
Hypotenuse.
Where is the hypotenuse?
Here. Because equilateral or X.
Oh, wait. Sorry, I did not catch that. Right. This is the equilateral. Okay, you're correct. Sorry, I was wrong. You're correct. I forgot that it's equilateral. Okay. Yes. Carry on. Okay, but what's sine 60, the exact value?
Sine 60. Oh.
Trick.
Oh.
Trick.
Sine.
Leave that.
Oh.
Let me teach you a calculator trick. Okay. Take out your calculator. Degree mode.
Yeah.
Sine 60, type in.
Sine 60 type in. Okay.
Enter. You get a decimal. Square it.
Yeah, 0.86. Oh, you square it. 3
Square
over
the
4.
exact answer.
Square root. So it's root 3 over 2.
Exactly. Calculator trick, must remember.
Yeah.
Faster. So the answer is root 3 over 2. Yes? Okay. Can okay, I write down already. Sine 60 degrees equals h over x, which is square root 3 over 2 equals h over x. Which one do we want? We want everything in terms of h. Love h, hate x. So we need to make x the subject. Sorry, can you see what I'm writing? It may help me to erase what you're writing. Then I will
Yes.
copy down whatever you wrote. So x over 2 is over here. Then that means that we which one do you want to keep? We want to keep h. So we don't want x, make x a subject. So if x is the subject, maybe one way to do it would be like this. X over h, I flip the fraction. Then on the other side, I also flip the fraction. That means I can bring the h over. Times. What do I get? X equals to 2h over root 3. Is that okay? Okay, very good. So that means that v will now be equals to, instead of 6xh, it will be, what's x? 2h over root 3. Or 2 over root 3 times a h. Simplify, what do we get? 6 times 2. The 6 can go to the numerator. 12 over root 3. Is that okay? 6 times 2 over root 3? Can 6 is the same as 6 over 1. Fraction times fraction, just multiply top and bottom. So 6 times 2 is 12, 1 times root 3 is 3. Okay, then h times h square. Is it clear?
Yeah.
Can? Very good. Wow, interesting question. Finally involve the x and the h. Okay, now move on to part 2. What does part 2 ask you to find? Okay, it wasn't labeled clearly, sorry. When the height of water in the trough is 1.8 meters, its depth is decreasing at a rate of 0.2 meters per second. Depth is the same as height. Find the rate of change in the volume of water in the trough at this instant. So what do we want to find? Okay, the only thing we need from part 1 is v equals this guy. Want to find? Last sentence.
And dv over dt.
Yes, exactly. dv by dt. What else is given?
Minus 0.2.
Minus 0.2 is what thing?
Is the depth, but then the depth is like what? How do I know which one is the depth?
Height is the same as depth. Yeah.
Oh. So it's
H is like a.
So dh over dt.
Give me a second.
Is it?
Let me read the question first.
Because while doing this question, I was also like, yeah, I'll stop by that.
Okay, it's sorry. The h is a variable. The h is like a variable. X is also a variable. So yeah, maybe it wasn't very clear because the h could be referring to the actual length of the triangle, which is fixed, right? Because it's a trough. You can't change the height suddenly. Only the water height and the water's triangular side length will change. So imagine if you had water that was around this level, then the height is like, I don't know, 1.5. Then the x here could be, I don't know, maybe 2.1. Then as water drains out, it becomes something like this level. Then the height here will be 0.8. Then the length here could be, I don't know, 1.2. It reduces a bit. So the h will decrease, the x will also decrease. Does it make sense? So h is like a variable, x is also a variable that changes. All right? Can? Okay, very good. So it's d what by d what? its depth is decreasing at a rate of 0.2 meter per second. You see meter per second is like a fraction, right? Meters is the units for a certain length. What length? The depth, which is the same as height, which is h. Seconds? Seconds is time. So t for time. So it's, oh, you wrote down already. So dh over dt. Yes. Okay. Then what else? What else is given?
When the thing is 18.
18? Oh, very tall, 18. 1.8, 1.8.
Oh, oh lol.
Okay.
The thing is 1.8.
18 very tall. Okay, 1.8 meters. Yes. Anything else? I think that's good enough. It's an equilateral triangular based prism. That's not relevant. Okay, maybe it's relevant later. We'll come back to it. So anyways, let's just start with what we want to find, dv by dt. What's the first thing you have to do? Split it up like a fraction. Top left, dv. Bottom right, dt. Then introduce d something, d something. Find something that is already available. What was given? dh by dt. What do you see here? D question mark by dt. It's like a wild card. You got played before Uno, right? Your hand. You had your I don't know. This is a very lame example. I don't know. Red, blue, yellow, green. You don't have green anymore. Your opponent before you put down green, but you have a wild card. What color do you choose? Choose green. You put down the wild card and you choose green. Make sense? Uno. So same thing over here. You see your opponent put down H. Your opponent is your teacher who set the question. H. You have a wild card here. What do you put here? What do you choose?
H.
H, of course. Okay, so H. But then you need to cancel off, so they have to be the same. So what do you put at the bottom?
DH.
DH, exactly. Okay. Chain rule. Complete. The Uno analogy, I guess, if you've played Uno. dv by dh over dv by dh times dh by dt. What's dh by dt? Negative 0.2, right? Yeah. Then what's dv by dh? Don't know. Then how?
1 over dh over, wait, no.
Sometimes you need to do that, but look carefully at v first. Where is v? Over there. V equals to something in terms of h. What can you find next? What can you find next? First step. Do you sub h equal 1.8? No. First step is
over dh. Okay, when
exactly
24 over square root 3h.
Very good. Exactly. Yeah, just
then
differentiate.
after that you sub the 1 point. Okay, no. Okay, this one.
Write down in terms of h first. Then the next line you write dv by dt. Vertical line.
Vertical line h equal 1.8 equal this thing inside, then h equal 1.8.
Very good. Yes.
We recycle.
Okay. Maybe more efficient way is the following. Vertical line h equals 1.8. Vertical line h equals 1.8. Vertical line h equals 1.8. Then finally you can write down the last line, so you don't have to write so much. In a sense.
So I can just from the start over here.
Yes, you can. But please show this working and show this working. Okay. Okay. Yes, you can. Okay, then what? Yeah, just sub in. I'll leave you to do it on your own. ... and then we get the answer. Can, right? This one? Sub in. Yeah, just calculator work. Don't need exact answer. You can try to find the exact answer on your own. Okay, that is question 15 done. Let's move on. Go, which is the next question. Question what? Question 19 is missing. Let's take a look at this interesting question. Okay, this is worth copying the picture. Give me a second. Let me go download the photo. Wow, slow. Oh no. Question. Okay, this is question 19. Let's take a look. So you have the following figure. It shows the curve y equals to 2x squared plus 3, whatever function it is. The point b, x comma y is a variable point. What does variable point mean?
I don't know.
It means you're allowed to move it
Move.
left and right. up and
Okay.
down.
Yeah.
Move along
Okay.
the-
Yeah.
It moves along the curve for 0 less than x less than 6. Means, can you have a b over here on the left side of
Yeah.
the axis?
Can.
No, cannot.
Where? Oh, okay. Less than. Oh, more than 0, less than 6. My bad.
More than 0. Can it be on the y-axis itself?
Yeah. Wait. No. Cannot.
Cannot. It will be x equal to 0. Not allowed. It has to be more than 0, so somewhere slightly to the right. Can it be exactly at x equal to 6? Y equal
Cannot
y
be
equals
at x equals 6.
2 times 6 squared plus 3 at that particular value, whatever it is. Just sub in the x. No, of course, because strictly less than 6. So it will go in between these two places. Okay? Whereas the x changes. Then C is a point on the x-axis such that BC is parallel to the y-axis. So what that is really telling you is C is always directly below point B, and it will form a 90 degrees with the x-axis like this. Can see? Okay, good. Which also means what? What's the coordinates of C?
Coordinates of C. Something 0.
But what is something? If B is x comma y, what is the x coordinate of B?
X comma 0.
Very good. So it's a variable x. You can, as you change the value of x, C will also change. How about point A? A is, let's read the question, parallel to the
A.
y-axis, and A6 comma 0 lies on the x-axis. Whenever they introduce it like this, A, then open bracket, number, comma, number,
Yeah.
it means that it's a fixed point.
Okay. Fixed point. Yeah. Okay.
Is fixed point. Fixed means what? Not variable. Not variable. Okay. It means it's fixed there. It doesn't move. Stays there forever. The B and C can change, but the A will remain. So maybe if I just do a quick sketch, give me a second to draw this up. Okay, so I'll just draw down, up, and then, okay, good. Then I will draw a fixed point 6 comma 0 here. I'll draw a few copies. Okay, point B could be somewhere here, 5.9 comma some value. Then your triangle will look like this, a very thin triangle. And the point C is directly below. So it's 5.9 comma 0. Make sense? This is the point B. Then you can move the point B a bit towards the left. So you end up somewhere here. Then it's like maybe 4 comma question mark, whatever the question mark is. You can just sub in into the y equal to x squared plus what was the number again? Plus 3. Okay. So it's 2 times 4 squared plus 3. Doesn't matter, huh? But what I want you to see is this picture. Can you see that the right angled triangle changes, but it remains as a right angled triangle?
Yeah.
Okay. Let's try one more. Maybe over here. This will be point B, which is like more than 0, right? So maybe 0.2, comma question mark. And this will be point C, 0.2, comma 0. Right? You can see the changes, right? Okay, just to make it super clear, let me use Desmos to draw it. Okay, let's do it. Y equals, you can see the chat screen. Can you see?
Yeah.
Can Okay, very good. Okay, let me just make it smaller. This is 5, this is -5. Ah, looks nicer. Okay, looks more convincing. Okay, we're gonna label a point B, which will be A, comma, sorry, I need this notation. I can't call it Y anymore, I'll call it f of x. Okay, then this will be A, comma, f of A. Oh, does it not work? Let me see, to introduce a slider A, does it make sense? No. Huh. Okay, let's see. Oh, right. Okay. Let me think. How do I do this? I thought it would be easy. Okay, let me see. A, comma, f of A. Yes, correct. Label, yes. Then I'll have to call it point B. Okay, I'll just call it point B. Then point C would be something that's A, comma, 0, a fixed point 0. I'll label it at point C. And a point A will be, what was the coordinates? 6, comma, 0. Okay, then I'll open the label tick and then I label as A. It's a bit far over there. Sorry, I can't draw the triangle. It will take a bit more time if I want to draw the triangle.
It's okay.
Okay, can I? So I hope you
Yeah.
can visualize the triangle. Then as I change the value of A, I can control it in between 0 to 6. I can change the set size, let's say 0.1. Then I can press the play button. Then you'll just move around. Can you visualize the triangle? Okay, it's going very far.
Okay.
Yeah, so all these different triangles. Okay, very good. You can go and play around and try and make this on your own. Okay, let me share back the iPad screen. Give me a second. Okay, so what you've just seen is something that is changing dynamically. Means as you change the x coordinate, the area will change, right? Can you see? Sometimes it's bigger, sometimes it's smaller. And how fast it's changing will also be affected. Like over here is a bit gentler, over here is a bit steeper. Correct or not? Change a lot faster. It's like going up a roller coaster very quickly versus going up a roller coaster slowly. Okay? So that's when you need to use rate of change to study this kind of changes. Okay, I realized that I need more space. Give me a second to move things around. Okay, this one go up. Okay, let's read the question. So blah blah blah, finally done with the picture, and we'll get to the question. Express the area of the triangle ABC, which is T cm square. So it's just T. In terms of x. T in terms of x. So let's do that first. Part one. T equals to what? What's the area of triangle? Half times
base times height.
Very good. What's the base? What's the height?
AC, which I guess would be 6 minus x.
Correct. 6 minus x. Correct.
And then
like
height
6 minus 5.9, 6 minus 4, 6 minus 0.2. So 6 minus x in general. Then height is?
y.
Very good. But y equals to?
But y equals to 2x squared plus 3.
Very good. So that means that you just end up with half bracket 6 minus x bracket 2x squared plus 3. Okay, so you just express the area of the triangle in terms of x. Good. Part 1 done. Next part, find an expression
for d
dt by dx.
over
Okay,
d. So you just differentiate this.
Exactly.
Okay. Okay, bring out the half and
bring out. Oh.
Okay. Let's see. Chain rule. Differentiate the first one and minus 1. In the second one plus 6 minus x and differentiate the second one. 4x.
Yeah, that's it. Good.
Half minus 2x squared minus 3 plus 24x minus 4x squared minus 6x bring down the half bracket
Good.
6x squared plus 24x minus 3 half minus 3x squared plus 4x.
Don't erase. Okay, one more thing to take note of is when you have half times something, right? You don't put brackets around the half. You
Okay,
should put
wait,
brackets
yeah.
around the entire
No,
expression.
yeah. I don't know.
The brackets
you know,
around
I
the
just-
half
Yeah, it just
can be left blank. Okay, please take note of that.
okay.
If not, it looks
yeah.
very awkward. It doesn't make sense. The half will only multiply to the first term.
Yeah, by the first. Yeah, I know.
Okay, can good.
Can,
So, anyways, this is the expression. Good product rule. Part 2 is done. Now is rate of change. Given that when x equal to 2, t is increasing at a rate of 0.8 units square per second, find the corresponding rate of change of x at this instant. What this means is maybe the triangle is somewhere here when x equal to 2. Okay. Okay, this is the triangle. Then it is increasing, right? What's going on with the x? I think x is increasing. I think it's moving from left to right. Yeah. Does it make sense? No, wrong. Cannot be.
Wait,
You know why? I think B is moving from left to right, but I realize it's wrong. Do you know why?
Why?
Look carefully. T is increasing.
The area increasing.
Area is increasing. What happens if you as
Oh,
x
but
increases?
if this becomes smaller.
No.
Wait, is it? But
If
I'm just
x-
assuming. I'm not.
No, you just see 0.2 go to 4, go to 5.9. X is increasing, right?
Okay.
What
So
happens to your
me
area?
going this way.
The area will be decreasing. Correct or not? This area versus this area versus this tiny strip of triangle decreasing, which is not the opposite of this guy, increasing. So it cannot be. X is not increasing. X should be decreasing. It should actually be going this way. Big X, medium X, small x. Okay?
Okay.
So just from this sentence, increasing, you can tell that x is decreasing. Okay? And okay, with that in mind, we can carry on. What's WTF and what's given? Let's write this down. Part 3. Want to find what? Corresponding rate of change of x at this instant. So dx by dt. T. Also, you expect this to be positive or negative?
Expect it to be negative.
Negative, because decreasing, right? Decreasing, negative. What else is given?
Given dt over dt. D capital T over dt.
D big T over D small t. Small t is always time. Yeah, so 0.8.
Then the one when x is when x.
This one positive or negative?
This one positive, increasing.
Because increasing. Because increasing, therefore positive. What were you saying? When
X equal to
x equal to 2. Okay, then we can carry on. Let's see. Oh yeah, by the way, y equals to 2x squared plus 3 was the equation. So what do we do? How to do?
dx over dt x equal to goes to, you like to do this over this, then this is given, then okay, this is 1 over dt over dx. Okay, then do this also. Okay, after that 1 minus 3x plus 4x minus 15 times 0.8.
Okay, don't need to write. You know what's going on, right? Sub x equal to 2.
Yeah.
Okay, good. Yes. ... Do it yourself. Okay. Your
Wait,
answer
what?
is fine. Okay, not important. Sorry. I thought it might be important.
Or like, cause it will be like near. Or
I was worried that you might have a y. Okay, don't have.
Okay, yeah.
Very
Okay.
good. The question was simple enough. Okay. Then we're done. Yes.
Corresponding rate of change of x. Why so confusing?
Yeah, that's just the way they phrase it. Okay.
What is that?
Yeah, rate of change of, okay, the standard phrasing will always be rate of change of, like let's say y, then this will be translated as dy by dt time by default. But if they say rate of change of, okay, maybe at this instantaneous rate of change, it's about the gradient of a tangent line. Okay, rate of change of y with respect to x, then it will be dy by dy. Hello.
X.
Dx, yes. Okay. When they say with respect to something, then that guy is at the bottom. Okay. Y is at the top. Can?
Yeah.
Very good. Then rate of change is done. We can move on. Yes. Oh my goodness, it's already 10.4. Okay. Let's go. Give me a second. I'll just add on to the differentiation notes. Wow. Why I cannot? What's going on? Wow. What's going on? It's not good. Give me a second. Okay. Oh, I took too long with mine, Stella. Okay, let's take a look. So, this was the plan I mentioned last week, right? Go through the homework, go through Maristella, optimization, find maximum, minimum. You can see the stretch screen. This is this topic I'm gonna talk about now is the most important topic that you have to learn in engineering. It is known as optimization. Okay, optimization. Let's begin. Give me a second. I need to send you another file. Wait. Oh, I need to find the file first. Oh no. Here. Here. Yeah, from Xingli. Okay. Yes. I'll just use the Xingli book. Yeah, slanted. Okay. How do I? Hey, I'm so sorry. The books are slanted.
I can use it. I can use it. No,
okay, good.
Yeah.
Okay, can yeah. So this is on differentiation. Oh, that's a wrong book. Wait. 12. Okay. 12. So have you ever thought about, I can, let's say you have a piece of rope and you want to use it to fence up an area of grass. If you've ever done that. Is there a best way to do it? Like let's say you want to use the least amount of rope to fence up a patch of grass, the largest area of grass. Is there a way to do it?
There's a patch of grass. There's a patch of grass. What's the
Then you want to draw some a rope to fence it up. What is the best way? What's the most cost-effective way? So in other words, you want to minimize the amount of rope. This is the kind of question that this topic can help to answer. Yeah, we can find the minimum. What is the best way that can help you to minimize the cost? Another way to think of another application of this topic will be, let's say you want to figure out what is the best. Let's say you sell fishball noodles, okay? Then you calculate, okay, how many bowls of fishball noodles should I prepare for the day? How many bowls of fishball noodle or material should you prepare, like fishball noodle and other ingredients? How much should you prepare to maximize your revenue? Then let's say that you have a graph that looks like this as your revenue or profit. Same or close enough, directly proportional. Then X would be the number of bowls.
Okay, then it's your answer.
You can just draw the graph if you have the graph. Exactly. That's exactly what you will be doing if you are doing what's called numerical approximation. Just draw the graph. Right? But here we teach you a way then you're using software, probably you're gonna use MATLAB or whatever. But before you can use MATLAB, you need to understand how MATLAB works. And it requires this topic. It's called differentiation optimization. What do you call it? First derivative test. Okay, the key idea here you need to realize is that whenever you have this maximum point, right? You see it's how it's a maximum. It's taller than all the other points. Right? Taller in what sense? Taller in the sense that the x comma y, what's so special about this y compared to all the other points, the y coordinate? Like let's say, for example, this is, I don't know, 2, 10. Let's say this is 1, 9. Let's say this is 4, what's a good value? 4. What's so special about this 10 compared to a 9 and a 4?
More.
It's bigger. It's biggest. It is the biggest. Let me use a different value. 5. 9. Sorry. 10 is bigger than 9. 10 is bigger than 5. It's bigger than all the other y coordinates, which makes it the maximum, right? So that means that you want to produce 2 bowls of fishball noodles, or maybe 200 bowls. Could be in hundreds. Okay, right? So this is the kind of thing you can figure out using differentiation if you know the equation of this curve. So what's so special about this point? What else is so special about this point is that if you draw a tangent line now, what's the gradient of this tangent line? The blue color.
Gradient 0.
No, gradient. Gradient equals 0.
Oh,
yes.
Gradient 1.
But you also 1. The gradient is 1.
Wait, I said 0. What?
Oh, 0, 0. Sorry, here only.
Wait, I said
but
0.
What's the equation then? Y equals in this case.
Y
2, 10.
Y equals to 10.
Very good. Y equals to 10. Yes. Okay.
Okay.
Okay. Not the equation not so important. That one later we already figured. You already know how to find equation of a straight line. Using derivative. Now you just need to realize the key pattern. Maximum point gradient is 0. What's gradient? What's the formula for gradient? Gradient function. That looks like a fraction. As a d.
For gradient function.
This is y equal f of x. dy by dx, exactly.
Uh-huh.
You already know how to find dy by dx. If you know how to equate it to 0, then you're done. You just need to solve this equation, then you'll be able to solve for this x. I'll show you more examples later, then it'll be clearer. The same story goes for minimum point. Okay, maybe this could be cost, a cost curve, and x could be number of balls of fishbone ruler. You want to minimize the cost. Okay, then this one will be what value? You want to figure this out.
Yeah.
Okay, number of balls of whatever fishbone ruler, FBN, fishbone ruler. Okay, then anyways, before we can carry on doing that, I'll just follow the textbook. I have to talk about this idea called higher derivatives. Okay, plus higher order derivatives. Okay, let's begin. Higher order derivatives. So basically, it's second derivative, third derivative, that kind of thing. Let me just introduce a notation first. So for notation wise, let's say you begin with y equal f of x equals to 2x cubed plus 5x squared minus 7. We can find the first derivative, that's dy by dx. Another way to write it, f prime of x. Then how do you differentiate? 2 times 3, 6, x squared. 5 times 2, 10, 10x, and minus 7 gets us to 0. But this itself is also a function, so I can label it as like g of x, right? Then how do you differentiate g? dg by dx, correct or not? Just change the letter. Or if you want, I can use the letter t. Why not, right? Can you see that? Right? It's just another function, then differentiate, just a funny notation, which will give you what? 6 times 2, 12x, and then there's a 10. But here you have to introduce funny notation. Here we introduce a funny notation. It's just a simple idea, differentiate another time. But we call this d2y by dx squared. Let me write down how to read it. Read as d2y.
What is this?
By dx squared. Okay, it's just a pronunciation. You already know how to do it. Just differentiate one time, differentiate second time. That's it. Nothing special. Then another funny notation, double prime. Make sense? Start with f, become f prime, f double prime. Okay, now you can imagine if you carry on, what would it be?
d3y by dx cubed.
Very good. Yes. And afterwards, you realize after cube, you don't know how to pronounce already. So you call it d4y by dx power 4, or the fourth derivative. This one is first derivative. The second one is second derivative, obviously. This one, f prime 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 x equals 12. Okay, so the d2t by dx squared. Can you see how this is? This should be index 2. Okay, okay. You get a constant. Then if you keep on differentiating, what do you get eventually? Differentiate 12, what do you get? So prime 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 prime. 0. If you go higher, what happens to a derivative of 0?
If you go higher, what happens to you?
F 1, 2, 3, 4, 5. Differentiate 0, what do you get?
Wait, is it not just 0?
Exactly, it's 0. And if you keep on going, 6th derivative, 7th derivative, and so on.
All 0.
All zeros, very good. It will always be equal to 0. Take note of that. And also what you need to realize is that, wow, so irritating. 1, 2, 3, 4, 5, draw so many tiny little numbers. If only there was a more efficient way if you want to use the F notation. And there is, let's say, you don't want to write down 4 tiny little lines. You can write down F, open bracket, 4, close bracket, bracket X. This one will be F, open bracket 3, open bracket X, close bracket. This one will be F, open bracket 2, and this one will be F, open bracket 1, bracket. Take note that these brackets over at the superscript is compulsory. Okay, it's not to not confuse you with the square and the cube. Okay, like for example, okay, I should fill in the blank first. Give me a second. This is d4y by dx4, d5y by dx5, yeah, so on and so forth. You usually won't go to such high powers. In fact, we only need to focus on first two. Okay, the rest is just extra. Yeah, you'll learn about this in the future in a topic known as Maclaurin series or Taylor series in engineering math. Okay, yeah, or H2 math also have I won't talk about it. Further, just focus on the first two derivatives. Oh, wait, one more thing, sorry. Another notation, even more notation, very funny, is y with a dot on top, y with two dots on top. Third derivative, y with three dots on top, okay? You will see this in physics. You'll see this in physics. I will focus mainly on these two only, okay? Clear? Can okay, can. Let's practice some questions. Oh yeah, the what do you call this? The difference between the square and the d2y by dx square. Okay, so next point is a common mistake.
Okay.
It's the main thing. Let's start with fx equals to 2x cubed plus 2x squared plus 2. Okay, f prime x will be 2 times 3, 6, x squared. This one will be 2 times 2, 4, x. Differentiate another time, you get 6 times 2, 12x plus 4.
Oh.
Okay, now this is d2y by dx squared. The previous one was dy by dx. Usually you write it on the left. Now take note that this is not equals to dy by dx, bracket to the power of 2. Different idea, okay? What is dy by dx, bracket power 2? This guy.
Is it the 6x squared plus 4x squared? Like as in the bracket then square?
Square, exactly, yes,
Okay.
which is a square plus 2ab plus b squared. Remember the identity?
Yeah.
Totally different, right? It is definitely not 12x plus 4. This one 6 x squared becomes x power 4. This one x power 1. So they are totally different. Are we clear on that?
Yeah.
Okay, now d2y by dx squared is not the same as the square of dy by dx. Don't go and do anything like that. Okay, good. That's one thing carried. Okay, let's try one of the practice questions. I'll just write it down for you. Practice. Let's say that you have this is a PN1, if you want to look at the textbook or the paper. V equals to t cubed plus 2t squared plus 3t plus 1. I just changed the letter y and x to v and t, respectively. Find the values of t for which dv by dt equals to d2v by dt squared.
Wait, what?
If this is true, then find or solve for t. Solve for t, yes.
Okay, dv over dt is 3t squared plus 4t plus 3.
Good.
And then differentiate one more time.
Read it. How to read it?
d2v over t squared.
Very good. Yes.
Okay, 6t plus 4. So 6t plus 4 equals to 3t squared plus 4t plus 3.
Very good. Let me just paste it over. Good.
Therefore, 3t squared minus 2t minus 1 equals to 0. And then calculator is 3 minus 2 minus 1. Oh, it's in the error. T equals to 1 or t equals to -1 over 3.
Very good. Exactly. Okay, you got it. The rest is all just practice. Should I go through?
Wait, no.
It's
later
just differentiate a few times. Huh?
No, later the question is like some, I don't know, question
A bit different.
some yeah,
Okay.
common thing like then I'm like
Okay, I will go through some questions. Let's look at question 3. So why I haven't got to maximum minimum. Okay, let's just carry on. So let's take a look at question 3. If exercise 12A, question 3. Y is equal to this function, a fraction. Find
Yeah.
our quotient. Find part 1, the coordinates of the points on the curve at which dy by dx equals to 19/4. Okay, this part I'm going to skip it because I'm sure you know how to differentiate. Equate to a value solve for x. You know how to do it.
Yeah, can.
I don't want to go through.
No
But
problem.
I'm just gonna solve dy by dx first because I need that for part 2. So differentiate. You see a quotient, you use what rule?
Quotient rule. Low D
Low D high.
Less high D low over low square.
Less is minus, and high D low is a 4. All divided by bottom square. I'm going a bit fast. Is that okay?
Yeah, go ahead.
Good. This one is 3 times 4, 12x minus 3. This one is minus 12x minus 16. They cancel off. Minus 3 minus 16, negative 19, all over 4x minus 1 squared. Okay, good. Very good. Now we can move on. Now you want to find the value of d2y by dx squared at the point 1/2, 11/2. So basically, what they're asking you to do here is that you have let me just think how the graph looks first. Goes 0, bring the minus 1/1/4, so positive 1/4 like this. Then if x equal to 0, you get 4 over -1, -4, which is something like this. Okay, the graph will look something like this. Okay, this is the graph.
Wait.
You will learn how to draw this if you are in H2 math. I'm not gonna teach you that. Okay, this one. Yeah, you can. Yeah, once you practice a few times, you can do this in like a few seconds. A lot of practice. Okay, so anyways, this is the graph, and then what? Alright, just a quick explanation of how I got the graph. This guy is because of I do long division. Essentially I see same degree 3/4. This is y equal 3/4. Oops, y equal 3/4. Then vertical line is substitute denominator equal to 0. You get asymptote vertical equal x equal. Yeah, so you can also draw the graph. Okay, and this point I realize is 0, something. I just realized it's negative after I sub in x equal to 0 in my head. Okay, very good. You get the graph. Then what is the question asking? They're asking you at the point 1/2, 11/2. 1/2, 11/2 is probably somewhere here. 1/2, 11/2. There is a certain d2y by dx squared value. What's the value? Very simple. All you need to do now is to find d2y by dx squared first. Let's do that. So differentiate. Oh, you realize fraction. Are you going to use quotient rule?
Wait.
d2y by dx squared. You have dy by
just take out the negative 19 and then bring out the 4x minus 1 on top to the power of -2.
Very good.
Then you can just use scalar rule. Is that what it's called?
Scalar rule, yes.
And then chain rule. So -2. And then 4x minus 1 to the power of -3.
This one is power rule. Chain rule is what follows next. D outer, then times D inner.
Okay, 4.
Yeah, sorry, my x looks like a bracket, sorry. Differentiate, and you get 4, very good. Okay, so let's just multiply, minus become plus, 2, 19, 38. 38 times 4 is 40 minus 2 times something. I cannot remember, never mind.
120 plus 8 times 4.
152, is it?
Yeah.
19 times 2 times 4, 152, very good. So 152 times 4x minus 1 power -3. Bring down becomes positive 3 power. Can?
So this d2y over dx.
But then they want at the point 1/2, 11/2.
So sub x equal 1/2.
Very good. Wow, very good. Don't need to say, also can understand. Sub x equal to 1/2. Even though it becomes a second derivative, you still do the same procedure, sub in the x coordinate. Don't get tricked by the y coordinate.
Okay.
Good. So sub in equal to half. I will leave that as an exercise. You can just key in the calculator yourself.
Yeah.
Okay. Yeah. So not that difficult. Okay. Question 4 is just introducing. Instead of numbers, they give you A, B, C. Yeah. Are you looking at the question?
Yeah.
Yes. I'm not gonna go through that. I'll leave some as homework. You can try on your own.
Okay.
I'm gonna go through question 5. Question 6, I'll leave as homework. Okay, so question 5, let's take a look. So what we have there, we have what's that? Y equals to x squared plus 2x plus 3. And then you have what? Show that the dy by dx bracket square plus d2y by dx square power 3 equals to 4y.
I feel like this one I can do though.
Okay, can do.
Yeah, I feel like I can do.
Okay, very good. Homework. Can. Show. So left hand side equal right hand side. Just find dy by dx, find d2y by dx square, then square it and cube it. Just make sure you know the notation. Then equal 4 times of y means 4 times of y, 4 times of this. Okay, 4 bracket x squared plus 2x plus 3. Just long-winded, you can do it and meet a bit of binomial expansion. Okay, very good. So, I mentioned for square, of course, I hope you know dy by dx
Different.
bracket
Yeah, it's different.
It's not. Okay, yes, good. In general, maybe coincidentally in certain cases, it's true, but usually not true, most of the time. Okay, moving on. Increasing, decreasing function went through already. Stationary point also went through already. I'm looking at page. What's the page number? I can't see. Okay, got cut off. 12.3 are stationary points. Okay, increasing, decreasing functions. Done. Stationary points, I think I went through already, right? I scroll back up. Stationary points, I'm sure I talked about it. Here, right? A peak, maximum, local maximum. Why do I say local? Because it is not global. Global means the strongest, the maximum among all. This is clearly not the case because there is somebody who's taller, another point that's taller. So this is only a local maximum. Likewise, a local bottom, a local minimum. It's not the smallest because there's somebody who's smaller. This is the global minimum. That is the global maximum. We don't talk about that in Amax. We just focus on local minimum. Sorry, let me try again. We focus only on the local maximum here at the top, as well as the local minimum at the bottom. Okay? One more thing is stationary point of inflection. If you see the curve here, looks like a sad face, right? The left half. If you look at the curve here, looks like a happy face, right? Right half.
Yeah.
When you change from sad to happy or happy to sad, you change emotion. This is known as a point of inflection. But if this, in the special case of Amax, you only focus on stationary point of inflection. Change from what we call change in curvature, not change in emotion. Change in curvature like this is a point of inflection. But if just so happens the point where you change has a tangent line that has a gradient of 0, we call this a stationary point of inflection. Is that clear?
Yeah.
Likewise, these 2 other points are also under the family of stationary points. Stationary means that dy by dx equal to 0. You can imagine if you're on a roller coaster, you go up, and then at the horizontal part, it's for a brief moment in time, you are stationary. You stop moving. Can you imagine that? Roughly. It's because your height is not increasing or decreasing. Then suddenly you go up all the way. Whoa! Until you reach here, you slow down very, very much. Until as if you're not moving at all. And then you suddenly go down. Whoa! And then you stop for a while and then go up again. Whoa! Okay? Can understand now? This is the idea of stationary points. Key idea is, I should draw a table for you. Or a mini flow chart. Stationary points can be split into 3 categories. First one is minimum, local minimum. Next one is local maximum. Next one is third and last one is inflection. So here to here, sorry, here to here, or here to here. This point. Local maximum will be something like this point. Local minimum will be something like this point. Stationary means dy by dx equals to 0. What's dy by dx representing? What function? Begins with letter G. R.
Gradient.
Gradient function. Yes, gradient of a what line?
Gradient of what line? Tangent line.
Tangent line. Must remember, gradient of a tangent line, the blue one. Okay, at a point. Okay, very good. Oh, I forgot to illustrate the idea of rate of change of a gradient function. Okay, let me just go to the example of d2y by dx squared again. Scroll back down. Oh, I should have. Okay, I'll edit the file later. I'll copy the rate of change idea to the bottom. Okay, so previously we were looking at this function, right? Y equal 3x plus 4 over 4x minus 1. Yes. Let me just zoom in on the relevant part of the graph. Zoom in as in like this. Okay, let me just copy down the function. Give me a second. Copy and paste like this. Very good. So let's copy down the derivative. So I have this fella here, which is dy by dx. I have this fella here, which is d2y by dx squared, and it's equal to this. Okay, let's examine what happens at x equal to half. What will we get? Let's just type in a calculator quickly. So for the first guy, negative 19 divided by 4 times 0.5 minus 1 close bracket then square, we end up with negative 19. The other guy, 152 over 4 times 0.5 minus 1 to the power of 3, we end up with positive 152. Okay, what does this negative 19 and positive 152 represent geometrically? Okay, maybe d2y cannot represent geometrically. Conceptually, what's negative 19?
Negative 19 is what is negative 19?
What is negative 19? Yes.
dy over dx.
Okay, which is the what function?
The gradient function of a tangent line on a curve.
Yes, very good. What is the point? It's half comma
equal to
11
half.
over 2. Right?
Okay.
Okay.
Mm-hmm.
Sub x equal to half. Yes. Take this function, sub x equal to half, you get this, which is 11 over 2. Okay, so you have a tangent line here whose gradient m equals negative 19. Is it clear? This concept? Okay, now what is d2y by dx squared equal positive 152? Ignoring the 152, focus on the positive. What does that mean? From positive sign, I can tell straight away it should look like this. It should be a what do you call this? A happy face. Do you know why?
Why?
Why? Okay, let me explain now. This one needs a bit of. This one is a bit more theoretical. Give me a second to redraw this a bit. I need more space. Okay, so what is d2y by dx squared? Let me enlarge this because this is more important. d2y by dx squared is really just d by dx of dy by dx. Sorry, I am going a bit over time. I hope you're okay.
Yeah.
I will not charge extra. So dy, can
Yeah.
Okay, so dy by dx, there are two interpretations of this, right? It's really just the gradient function. So it's why do you call it gradient function? Because it provides the gradient of a tangent.
Yeah.
Provides the m of the tangent. What's m? M is gradient. Y equal mx plus c. Another interpretation is the rate of change function. Right, like dy by dt. Rate of change of y with respect to x. With respect to time. Right, rate of change. How fast is y changing as t increases? That kind of thing. Or just now the dt by dt. How fast is the area of the triangle? Remember the triangle just now? This one? Point B, point A, and point C. Remember? How fast is the area changing with respect to time? Little t is time, big T is area. So it's asking how fast is it changing. So if you look at outer d by dx against this inner dy by dx, dy by dx is itself a function, right? So if you let g of x be equals to dy by dx, this will really just be d by dx of g of x, right? This, I use g because it's the gradient function. G for gradient. Make sense? Gradient now. So what does it mean when we talk about rate of change of gradient function? We are really asking you how fast is the gradient changing? Here we see a positive sign, right? Here we see a positive sign, right? So that means this is more than 0. Does this look familiar to you?
Yeah.
What does it mean? Derivative of whatever more than 0.
Gradient more than 0.
More than 0 is a what function?
More than 0 is an increasing function.
Very good. So we conclude that g of x is increasing. Sorry, you know this notation? Okay, I don't confuse you. I spell it out. Is increasing function. So what does that mean? The gradient function g of x, I highlight in purple again. The gradient function is an increasing function. What does that mean?
What does that mean?
Gradient function is an increasing function.
It's
It
more
means
than...
the gradient function will give you values which are increasing. So you can imagine g of x will start off with negative, then you'll go to 0, and then you'll jump to positive. Does it make sense? Increasing, increasing must go from negative to positive. Understand?
Yeah.
So maybe I'll write this down. I need more space. Okay, give me a second. Add a page. This implies that, okay, maybe I should on a new page. I should write this on a new page. Give me a second to adjust this. Second derivative. Okay, this is the header. Okay, this implies that g of x, okay, no. Increasing function means as x increases, g of x also increases. So g of x can be, for example, negative 19. Then eventually g of x will grow into negative 10. Then it will grow to, okay, don't grow so slowly. Just grow to negative 1. Then g of x will go to 0. And g of x will go to positive 1. And g of x will go to positive 10. Okay, something like that. That's what increasing means. Does it make sense?
Yeah.
Yes, but what is g of x again? G of x is the purple guy, which is the gradient function. So in terms of gradient, right, can you translate this into a picture? Negative 19, how do you draw So that means that gradient is negative 19. How would you draw the picture of the tangent line? Don't care about the curve. Negative gradient, how would you draw it? Can you sketch for me? Don't care where's the y-intercept. Okay, don't draw y-axis. Draw for me. Negative. What sloping? Okay, negative. Okay, so something like this. Yes? Okay, I'll just draw one huge x-axis. Because this is as x increases. So this is negative 19. Maybe I should make it super steep. Then as x increase, we move a bit to the right, it becomes -1. How can you draw a sketch for me now? Yes, gentle curve. Then if it's 0, horizontal. If it's +1, it's a bit gentle but positive. If it's positive, then it becomes super steep. So this is like a map. This is an indirect way of sketching the curve. Can you see?
Okay.
An indirect way of sketching the curve because there is a hidden curve over here. By looking at the gradient, okay, can you help me to erase your drawing? Yeah, okay, by looking at the gradient as you increase the value of x, you're able to tell the shape of the curve. Happy face. Can you see? So what does it all mean? Conclusion. This guy is more than 0, you get increasing function. A bit difficult to understand. So the shortcut is to realize what is this guy. It originally came from this guy. And this guy is really just the second derivative. Second derivative is more than 0. Straight away jump to the final conclusion. Happy face. Clear? Okay, let's write down this conclusion. Happy face. That's a technical word for this. Concave. Let me think again. I always mix this up. Upwards. Okay. How do I remember this? CUP, cup. How does a cup look? Teacup or something like this. Oops. Okay. So happy face. Happy face. Teacup. Then what happens if it's less than 0? Very good. You can use the same, try and think about it yourself. Why should it be a set face? Go through the logic, then see if you can make sense of it.
As x increases, gx decreases.
Correct.
Okay.
And how would the tangent lines look like?
How would the
that face?
tangent lines look like?
You start from the left. Tangent line, this one, super
Left
positive, right?
Yeah.
This one only slightly positive, then becomes 0, then becomes negative, then super negative. So super positive all the way to super negative is an increase or decrease?
Decrease.
Decrease. That's why this guy will decrease. Okay, so therefore you can roughly get the idea. d2y by dx squared less than 0 implies it's a set face. Okay? Very good. Okay, so what else can you conclude? If you additionally know, it's let's say combine one more page. Okay, let's say that now you know there's a graph here. You found this point 2, 10. I don't know where this function came from, y equal f of x, whatever the function is. You manage to realize that this guy dy by dx equal to 0, you solve and then you get x equals to 2. Then you sub in, you realize that f of 2 equals to 10. Okay, f of x, replace the x equal to 2. I hope you are familiar with the function notation, which implies that 2, 10 is SP. Stationary point, okay? I hope you you can get used to this notation. SP stands for stationary point, where a point where the gradient has 0, where the tangent has gradient 0. This point. But do we know if it's a, how do we know if it's a maximum or minimum? Okay, one obvious way is to plot the graph and stare at it. Is this maximum or minimum? 2,10 here. Hello.
Not sure.
Not sure. Maximum or minimum?
Oh, maximum.
Maximum from looking at the graph. But usually the function that will be given to you by the question, this f of x, is very complicated. Problem, obviously maximum. But this guy, and also maybe the context, maybe if you're doing a question that involves what do you call it, profit. This is a profit function. Then obviously you want to find maximum profit. So it will be very obvious that it's maximum. However, let's say that you didn't know the context, you didn't know this is a profit function, you know it's a general function f. You also know by that it's super obvious by just staring at the graph that this is a maximum point. However, from a theoretical point of view, we like to quiz students and we pretend that you cannot see the graph. Pretend that you cannot see the graph. Can you still tell that it's a maximum? Given that dy by dx equal to 0?
No.
No, because it's ambiguous. What's another possibility when dy by dx equal to 0? Or
Yes.
two other possibilities?
Wait.
Two other possibilities. Remember flow chart I draw for you? Remember? Stationary point. What are the 3 cases? Maximum points, brother, is?
Minimum point.
Last one is when you change emotion. Sad face, become happy.
In point of
in inflection. Okay. So let me just draw it nicely. This guy or this guy. Okay. This is point of inflection. When you, what we call, have a change in curvature. Let me write it down. Change in curvature. Happy change to sad, sad change to happy. Okay, Ken. So let's just pretend that we are very I don't know, theoretical mathematicians, and we like to ask ourselves, hey, pretend that we cannot see the graph and we cannot tell that it is obviously maximum. How can we finally conclude that this must be our maximum point? Here are a few ways you can do it. Let's examine the graph. I zoom in a bit. So copy and paste. Okay, then I make the graph look bigger. How can you tell that it is a maximum? 2 ways to do it. First way. What do you see? You see a stool. You see pie.
Yeah.
Campfire. Some put your mess in. No. This is positive. This is a tangent, and a tangent.
Sad face.
Sad face. Okay. More importantly, I want you to focus on the tangent actually.
Oh.
Yeah. Oh, let me move the tangent line a bit closer. And here, let me draw the tangent a bit more horizontally. Okay, so what you realize is that the tangent on the left is a bit positive. The tangent in the middle is 0, m equals to 0. The tangent on the right is negative, which will give you a sad face. If you know this is 0, you know it's a sad face. What do you conclude about this particular point here? Let's call this point P. P is a, like previously, if we only knew m equal to 0, in other words, dy by dx equal to 0 at that point, we couldn't conclude anything because it could be a happy phase as well, which is a minimum point. But the other case is a set phase, which is a maximum point. But here, once we know it's a set phase because of the gradient, right? And we know that this gradient of the tangent at this point P has a gradient of 0. The gradient of this tangent line is 0 at the point P. What can we conclude about this point P? 3 category, which one?
P is maximum point.
Very good, maximum point. So how about the other case? Let's say, oh, sorry, I can't use the same diagram anymore. You draw opposite diagram. Let's say it looks like this. Point P, I don't know, don't call it P anymore. Let's call it Q. Make it different. 3, -2, it doesn't matter. If we know that this has a gradient equal to 0, dy by dx equal to 0, is that enough for us to conclude it is a minimum point? Is this enough?
No.
No, because there could be its evil twin or good brother, which is the set phase. Then it will have a maximum point while also having dy by dx equal to 0. So it's ambiguous. How do you remove the ambiguity? You can draw a bunch of tangent lines around it. A bit to the left, a bit to the right, at a particular point, at a particular point. This one also at a particular point, at a particular point. And then you realize something special. What's so special? The sign of the tangent is special. What sign is this? Plus or minus? The gradient, sorry.
Negative.
Negative. How about this one? M equals 0.
0.
And the right one?
Right one. Right one is increasing. Positive.
No. Positive. We don't care about whether increasing or decreasing for now. Just positive. Okay. So if it's a bit to the left negative, then 0, then a bit to the right positive, we know without a doubt now that this point Q here, let me just, actually this set is not so important. Sorry. I mean, is it important? Not very relevant. We know it is a happy phase now, but it's not very relevant for now. What we need is a conclusion, which means that this point Q here is our not maximum, but
minimum.
Minimum. Okay, very good. Okay, good. I just went through the first derivative test. Did you catch that? This is without example, without numbers example, so it's maybe a bit difficult to understand, but you must capture the idea. A bit to the left, the gradient, a bit to the right, the gradient, and the gradient right in the middle. Plus, then 0, then minus, tells you that this is maximum point. Set phase, maximum point. Clear?
Mm-hmm.
Then the other case would be negative gradient, 0 gradient, positive gradient, happy phase, minimum point. That's one way to do it. But you could have also concluded that it's a maximum point because it's a set phase. It's a minimum point because it's a happy phase by a different way. I mean, you need to first figure out how is it a set phase, how is it a happy phase. And I just explained previously, right? You can determine happy or set phase by these fellows, right?
Mm-hmm.
Correct? Okay. So this one set, this one happy is actually a separate path. Let me bring it down. If you know, this is graph of y equal f of x. If you know that dy by dx equals to 0, you can proceed in this way. Let me make it look nicer. Sorry. Make it look nicer. I want to make it into a graphical chart. Maybe something like this. If you know that from a graph dy by dx equal to 0, that's your first step. There are two paths to proceed to figure out whether it's a maximum or minimum point. First path, you draw the graph. You draw the tangent lines. Or you don't actually draw it. You just want to care about the sign of the tangent, the positive, 0, negative pattern. Then you conclude it's a maximum point, in addition to the dy by dx equals 0. This is the first path. The second path is dy by dx equal to 0. Then you figure out d2y by dx squared. In this case, you want a set face, right? When do you get a set face? When do you get a set face? d2y by dx squared is? Oh no, it goes both ways, but what about d2y by dx squared?
Less than 0.
Look, d2y by dx squared is saying the derivative of the rate of change of the gradient function, right? Gradient being first derivative. Rate of change of the gradient function. Look at the gradients. Positive go to 0, go to negative. What's the change? Decreasing. Decreasing means derivative must be more than 0, less than 0. Decreasing.
Decreasing means must be less than 0.
Less than 0. Less than 0. Is it correct? Let me just double check. Okay, can. Correct. Less than 0, then you get decreasing gradient, which means that you have a set face, which means you have maximum point. Is that okay? Can Okay, I'll remove this because it's messy. Likewise for minimum point, you just go in a parallel path. Maybe I should do this. Split. Then from here, wow, it looks bad. Let me try again. Like this. 2. This one part 1. This one part 2. d2y by dx squared. Of course, it must be the opposite this time, more than 0. Then you'll get a happy face. And then you conclude Q is minimum point. Let me try and make it look symmetrical. Can? Does this make sense? This logic? Okay, now let's try one question. Wow, very late. I am so sorry. It is so late. Let's try one practice question. Can?
Okay.
Let me see. What is a good example to determine the nature of stationary points? Okay, maybe I will assign 12C as homework. I'll just try some questions. Okay, let's take a look at question 8. Look at exercise 12C, question 8. Let's take a look at question 8. What's the curve? Can you read for me? Y equals
to 2x squared over x squared plus 1.
Very good. Okay, part 1, show derivative. So dy by dx. What do you see? What do you see? This guy.
A quotient rule.
Oh, what rule? Okay, yes. I'll just do it quickly.
Less high to low over square, low square. Low square.
Very good. Less high the low.
The top will equal to 4x.
Yes, it will equal to 4x. Let me just expand it out. Plus 4x minus 4x squared. Wait, no. Did I mess? Oh, cube. Right. Cancel. Get 4x. Can.
Find coordinates of the turning point determine the nature of this curve.
This is a very standard question. Part 2 now. Find the coordinates of the turning point. So there's two parts to the question. Coordinates. My short form for coordinates is just coord. Coord of the TP, aka SP. TP is not toilet paper. TP is turning point. SP is not Singapore Poly, it's stationary point. Okay. Both are the cases where the gradient of the tangent is equal to 0. Okay. Let me just show you how to do it. First thing is you write down for SP or TP. I like to use stationary point.
For SP.
Oh, one more word. For SP, for stationary points, in this case, the book said turning point is the same thing. They are synonyms. AKA means also known as. Also known as. I write all these short forms, but I still write the full form. Okay. Set dy by dx equal to 0. Can? Then you take the dy by dx. You equate to 0. So what we are doing is we're really finding the gradient function equated to 0, which means that the graph can look like nonsense like this, but we are equating to, finding all the points where there are gradient with 0. How do I phrase it? Where there are tangents which have gradient equal to 0. Okay? These points, these 3 points, like for example. Okay, let's take a look. How do we solve this equation? 4x over something square equals 0.
Wait, how do you?
How? Yes, correct. That's it. You just cross multiply this over, but you realize 0 times anything is 0. So right hand side becomes 0, left hand side is 4x. Then you can divide by 4. 0 divided by 4. Oh, that's just 0. Yes. As easy as that.
Okay. So
Step 2. Determine the nature of this turning point. Sorry, turning point coordinates are not done yet. Because
sub x equals 0 into sub x equals to 0 into the curve they give. Right?
The curve they give. Let's label this as equation 1. Then just say 1. Done into 1. This one step 1. Label this
0 over 1. 0 over 1.
Correct.
So
0 over 1, which is 0. So therefore, the conclusion is SP 0, 0. Yes. Good.
Okay.
Step 2. Now, step 2. Determine the nature. So this, I just now remember the path I showed you. Let me just take a screenshot of this. Then I'll paste it somewhere at the corner. This procedure, there are 2 paths to take. Step 1 is done. Now we are doing step 2.
Yeah.
There's part 1 or part 2. You just need to remember one of them. And then the conclusion. I'll just show you the first method 1. Okay. No, I'll show you both. Method I or method 1. I label as 2.1, part 1. So I'll just label as part 1. This is known as the first derivative test. What we do is we want to figure out what is the gradient of the tangent lines to the left exactly at the stationary point and a bit to the right. Okay. So what we do is we draw a table. Many different teachers have different tables. I draw my own version. X, draw a column. Then I will label what is there? What was the x coordinate of the turning point? Turning point was SP or stationary point. X coordinate is this guy, 0, right? So what I'll do is I'll label x equals to 0 minus vertical line, x equals to 0, vertical line, x equals 0 plus. Okay, zero, a superscript top right corner minus and a plus. Means it's slightly smaller than zero, slightly more than zero. Draw a line. Gradient. Gradient means gradient of the tangent line. So you don't need to give me the, what do you call it? The actual number. You just pick a random number. Let's say we pick x equals to negative 0.1. That's slightly smaller than zero. What I want you to do now is help me take your calculator, sub in into y.
Okay.
Y equals what? 2 times negative 0.1 square.
So divided by divided.
Remember to bracket before you square.
Oh,
Approximately.
x square super 1 square plus 1 square to 0.019605920099.
How come got 605? Oh,
Wait, what? Wait.
Oh, sorry, not y. I don't want y. I need the dy by dx. Sorry.
Okay.
Yes. Did you do it correctly? I think I did it wrongly. 4 times negative 0.1. And negative 0.1 square plus 1 bracket square. Did you get this value? Sub in into dy by dx, not 1. I apologize. Wrong.
Wait, can you scroll
dy
up a
by
bit?
dx. Yes. dy by dx is this guy. 4x over
Okay.
x square plus 1 bracket square.
Square plus 1. Yeah.
Okay.
Okay. I get that. Minus 0.321184198.
Okay, good. The main conclusion is the sign minus.
Minus gradient.
What I want you to do is draw a negative gradient graph like this. Okay, then x equal to 0. You can try substitute x equal to 0 into dy by dx. What will you get?
X equal to 0 into dy by dx. You just get 0. So the
Exactly.
gradient is just flat.
Correct.
Then sub positive 0.1 get positive get negative gradient.
Yes. Let's just record it down since this is the first time you're seeing this. Ui by dx equals to record the value. What is the value?
Negative. Yeah. I just wait.
4x over x squared plus 1 bracket square.
Or 0. It's just the that value but positive.
Very good. Because of the square, there is symmetry. So when I use the positive version, it will just be positive. Purely coincidental, okay? Not always the case. Can? Positive gradient, then how? I realized I draw wrongly. Negative gradient, I draw positive. Oh my goodness, I'm tired. Negative gradient, 0, then finally positive.
It's minimum point.
Very good. And then also help me to write down one more sign. Minus sign, 0, positive.
Positive, okay.
And this implies minimum point. This is first derivative test. Let's try what is known as the second derivative test. Let's go. Not done yet. Method part 2. Second derivative test. You either do method part 1 or method part 2. Choose one. Pick one that is easier for you. Usually students will pick method 1 because it's easier. You realize that there are no numbers here, so it's faster. All you need to do is to figure out the sign. Okay. Right, figure out plus or minus. Then you know it's a maximum or minimum. Okay. Wait. Let me just extend my table, draw another row. Okay, so it's like this, x gradient sign. Next one is second derivative test. This one requires you to find the second derivative, of course. So what's dy by dx first? Dy by dx was 4x over x squared. Wait, I wrote it down over here. I'll just paste it. So what do you do to find d2y by dx squared? Just differentiate it again, right? Okay, so again, it's a fraction. So what rule do you use?
It's a fraction. What rule do I use? Quotient rule.
Quotient rule.
Low d high less high d low over low square.
Less is minus. Must remember this one. Okay, but I've seen your work. You know what's going on. That's high d low. So this one, high d low, what do you get?
D low, you get x squared plus 1 to the power of 4.
Low square, yes. But then, no, I'm asking about the second term of the numerator.
Oh,
High d low.
oh, you get chain using chain rule. Okay, you have times 2 first, then times x squared plus 1, then to the power of 1, so don't write anything, then times d inside 2x.
Very good. Yes, 2x. Okay, chain rule. Okay, you understand. Clean up. Okay, so what we get? Here, please don't expand. Usually, you don't want to expand this second derivative. Leave it as a square. Keep. Then you carry on, expand everything. This guy is, let's see if there's any tricks I can do. Sorry, cannot. This one, no choice, must expand. Numerator need to expand. Let's just do it. So what we end up with is, actually, is there a trick? Oh, wait. There is, but very messy. Okay, you know what? I'll just do the following. I'll keep the square, keep the 4, leave it alone. But this one I clean up. 4, 2, 2 is 16, right? Okay, 16 with a minus sign. Then you have a x times the x is a x squared. Then after that, you have x squared plus 1 to the power of 1. Okay, can? Let's just factorize out something. I notice as a x squared plus 1, I can factor out. Clever trick. What am I left with? It's 4 times of x squared plus 1. Okay, this is like power 1, which gives you the, if you multiply them together, you get the power 2. So factorize complete. Minus, I realized there's a 4 and 16, so I can factor out a 4 here. This becomes a 1. I don't need to write the 1 anymore. 1. Then 16 divided by 4 is 4. Take out x squared plus 1, you're left with x squared. Right? Clear so far?
Yeah.
Or divide by x squared plus 1 bracket square. Okay, can. Then carry on. So 4 x squared plus 1. Don't forget to simplify this a bit. X squared plus 1 minus 4x squared become negative 3x squared. So there's a 1 minus 3x squared all over x squared plus 1 bracket square. Now, what we do in the second derivative test is to sub in x equal to 0. This x equal to 0 came from the x coordinate of the turning point or the stationary point, which was 0, 0. You sub in this guy. Ignore the y, focus on the x. Can? Then you check the value d2y by dx squared when x equal to 0. Then you figure out what's the sign. So let's do that. Oh, it's a 0. That's not right. Let me see. Did I do something wrongly? Oh, no. My brain's not working. Sub in x equals 0. No, it's not. It's not 0. Okay, let's see what it is. 0 squared is 0. Don't forget a +1. 1 minus 3 times 0 is 0. So 1 minus 0. All divided by 0 squared is 0. Plus 1, then bracket square. What is this value? Tell me the value.
1/1.
Huh?
Wait, I mean 4.
4, which is more than 0. More than 0 means happy or sad face.
More than 0 means happy face.
The rate of change of, let me think, rate of change of dy by dx gradient function is more than 0 means gradient function is increasing. Increasing means negative to 0 to positive. Negative to 0 to positive.
Happy face.
So as a result, we end up with this shape, happy face, which means that this is our minimum point. This point here is 0, 0. P, okay. Or Q, I don't know, doesn't matter. Can?
Wait, can scroll a bit? Wait, can't see them.
The procedure, this one?
Wait, how you know? You know that x is 0 because
from the x coordinate of the turning point. Right, remember?
You know x coord of turning point, cause like from just now, like
from
okay.
First step, step 1.
Yeah, okay.
Okay, now we are at step 2, method 1, the short one, or method 2, the long one. Sometimes method 2 can be easy once you're super familiar with how to do differentiation. Some students, they prefer second derivative test. It is up to you which one you want to use during an exam. Okay. Yay, done. Okay, that's it. Yeah, that's just one example. I haven't shown you inflection point. Your homework I will assign later, and that will be all for today.
Okay.
Okay. Most important topic learn. Okay, I don't have to break. Bye bye.
Thank you. Okay,
Thank you. Bye bye.